Yes, Siddharth ji, I am audible.
Yeah, good evening, sir.
Good evening. Yes, let me start. Tell me something about you.
Yes, sir. So my name is Siddharth Jain, and I have done my schooling from St. Anselm Senior Secondary School, Bhilwara. Then I went for my graduation to the Central University of Rajasthan. From there, I completed my graduation in 2017. And in 2017, I gave IIT-CHEM exam. After that, I got selected in Indian Institute of Science. From there, I did my post-graduation. And during my post-graduation and after that also, in 2017 and 2021, I qualified CSI and NET exam. And in the year 2021, 22, and 23, I have qualified the GATE exam. And recently, I am preparing for the government jobs, and I have appeared. I am appearing in this interview.
Yes, good. Yes, today mock topic is chemical kinetics. Yes,
Yes, sir.
yes. Let me start. Explain on whiteboard. Basic
Okay,
to
sir.
high. Yes,
What, sir?
basic to high.
Okay. Yes, sir.
Okay.
So, chemical kinetics.
Yes.
In chemical kinetics, we see that there are two terms, chemical and kinetics. So what is mean by chemical kinetics? First thing comes in our mind. So chemical kinetics means like chemistry, and kinetics means rate. So it is a chemistry or branch of chemistry which deals with the rate of reaction. So it deals with rate of reaction. Now, what is mean by rate? So if we define the term rate, rate means change divided by time, because change per unit time. So what is this change what we are looking for? The change in concentration. Right? What is the change in concentration with respect to the time? We define this as the rate. Now in chemical kinetics, when we define the rate, the first thing that we need to know that the rate change that is happening. So I will take an example for this. Like for a reaction A plus B goes to product. Let's say initially I have 1 mole of this and 1 mole of this. And initially the product has 0 moles. Now after some time t, like 10 seconds, I got 0.5 mole of this, 0.5 mole of this, and 0.5 mole of products. So the rate which I will define is like here the moles of A has changed from 1 to 0.5 divided by how much time? 10 seconds. So it is 0.5 divided by 10. It is 0.05 mole per second. I have written mole per second here because we are just considering the moles here. And if we consider the concentration term, then we can write as concentration. Now, when we know about the rate, the second important thing which we need to know is the order of reaction. Order of reaction. So, what is mean by order of reaction? So, I will take the same example, like A plus B goes to product, and initially I have 1 mole, and 0 mole. Then after time 10 seconds, it got to 0.5, 0.5, and 0. So, order of reaction means that how the rate is varying with respect to these concentration terms. Like if I write rate is proportional to, since we have already seen that rate is changing concentration, so I will write rate is proportional to the concentration of A and rate is proportional to the concentration. But it might not be the same as like we are having power 1 here. So the rate may vary with other powers also, like it can be A2 B1 or it can be A 0.5 B1. So the total amount of these coefficients which are written on the power of the concentration terms, we call this as order of reaction. So I write sum of power of concentration terms in rate equation. Now, why this order of reaction is important? Because on defining the order of reaction, we define different type of reactions. Like based on the order of reaction, we define zero order reaction. We define first order reaction. We define second order reaction, and so on. It can be up to infinite orders. The reaction can be up to n orders. So let's briefly discuss about what are these order reactions. So first, zero order reaction. So what is meant by zero order reaction? Like I have already told that order is the sum of the powers in the concentration term of the concentration in the rate. So I can write for zero order, rate is equals to, rate is proportional to power of, like if a concentration reactant A is there, then it will have power 0 because it's a zero order reaction. So since rate is defined as dA by dt, and since the concentration of product will be decreasing, so we write the minus sign, and it will be equal to, where K is the constant for removing the proportionality, and A to the power 0. And if we integrate this equation, with limits like minus dA, A naught to A equal to integral A dt 0 to t. Here A naught is the initial concentration, A is the final concentration, and time is A from 0 to t. We get A naught minus A equal to K. This is the rate law for zero order reaction. Now similarly for first order reaction, we can define as rate is proportional to the concentration of A to the power 1. And if we write the rate again, we get dA by dt is equals to K concentration of A. And again, if we take the limits from A naught to A and 0 to t and integrate this equation, we get the form ln of A naught upon A equal to K. This is for the second order, first order reaction. And if we take for the second order reaction, now in case of first order and zero order, we are having only one concentration term. But in second order reaction, there can be two types of second order reaction. For example, if twice of A molecule is getting converted into a product, this can be one case. Or if two different molecules are colliding and they are forming the product, like A plus B goes to the product. This can be the second case. And if in this case we derive the rate law using the constraints like concentration has changed from A naught to A and time from 0 to t, we get the equation this is the equation for the rate law which we get. Now let's move to the next thing, because these are the simple order reactions and which are usually studied in 11th and 12th. So let's move to the next one, which is the theories of rate of reaction. Now in theories, we are having two different types of theories given which define the rate of reaction. First one is collision theory. and second one is activated complex. Now, both these theories are given for biomolecular reaction, for biomolecular reactions only. They are not for the unimolecular reaction. So this is one important point about these theories. So let's discuss the collision theory first. So in collision theory, we are having the principle, like first point about the principle of the theory is that the molecules are colliding with each other to form the products. So collision is must. First point we can write is collision is must between the molecules. Second point is that not all the collisions will lead to the formation of products. The most important point is that not all the collisions will lead to the product. So there need to be an effective collision. Now, what is meant by this effective collision? That it should have three things. First thing, it should have energy. Second thing, it should have steric factors. And third thing, it should have the collision number or collision frequency. So these are the three factors which will define the rate of the reaction. So we can write that rate is proportional to collision frequency energy factor into steric factor. So if we try to derive all these three factors, we can define the rate by using the collision. So let's derive all these three. So for deriving the collision frequency, let's consider a case when A plus B goes to the product. Now in this case, we are having A molecule is reacting with the B molecule and the product is forming. So we assume that A molecules are getting collided with the B molecules. Yes. Now, if we add the collision frequency, then we should know how many collisions are taking place in the reaction when A and B are colliding together. So from the gaseous state, we know that collision frequency or collision number, that is ZAB, is given by pi sigma AB square 8 KUT 1 pi to the power half NA star NB star. Now in this equation, we are having three terms. First one is sigma AB, then other one is this term, and then this term. So sigma AB is defined as closest distance between A and B. Since both the molecules are colliding, so if we look at the closest distance, then if we join the centers of B, then this will be sigma. And this 8 kBT by pi mu is the average energy, as we have already derived from the Maxwell equation that the average energy formula is good. And Na star and Nb star are the number densities of A and B molecules in the system.
Yes.
So now we know that every collision will not lead to the product. But for a case of deriving the factor, let's consider that every collision converts to product. So in this case, we can define the ZAB, that the collision number will be the maximum rate which we can achieve. So we can write this as R max equal to ZAB. or we can write is minus d Na star by dt equal to. So if we use the rate law for the bimolecular reactions, then we know that the rate is equal to K concentration of A into concentration of B. And we can easily calculate the concentration of A and B because we are having number densities of Na. So if we divide by Avogadro number Na, we can get concentration of A. And if we divide Nb star by Avogadro number, we can get concentration of B. So using this equation, we can write that minus 1 upon Na d Na star by dt is equals to K concentration A Na star upon Na into Nb star upon N implies B of Na star by dt equal to K Na star Nb star upon N. Now, since we know that the value of ZAB is equal to the value of minus d Na star by dt, so we can equate both these equations and we can find the value of rate constant. So if we equate both the equations, we get K equal to Na pi sigma AB square 8 kBT 1 pi mu to the power half. So this is the value of rate constant which we get from the maximum rate. So this is the case when all the collisions are leading to the products. But since we know that all the collisions are not leading to the product, we have to consider the two factors, which is energy factor and steric factor. So for considering the energy factor, we know that for a product to form, there needs to be an energy which it has to gain, which is called as activation energy. And for achieving that activation energy, there was an equation given that the energy is proportional to RT ln of K. So using this equation, we can write K is proportional to exponential minus epsilon naught or EA by RT. So we get the energy expression from this term. So we can write using this factor that K equal to Na pi sigma AB square 8 kBT 1 pi mu to the power half exponential minus epsilon naught by R. And the third factor that we need to use is the steric factor. Now, why this steric factor is important? Let's briefly discuss about it. For example, if a reaction H2 plus Br is reacting to give HBr plus H2. Now, if H2 is reacting, so H molecule is present in form of a bond. And if we react it with the Br molecule like this, or there can be other case when H molecule is reacting with the Br molecule. Now, when the molecule is in this orientation, the energy change which occurs for this orientation, if we plot with the reaction coordinate or potential energy versus reaction coordinate, then we will observe that for this case, as represented by the dotted line, there will be a large change in potential energy as compared to this. So the static factor comes into the play, and we can say that the static factor determines that reach of energy will be much higher in case of A as in case of B. So the static factor is defined as by a constant P, and it's different for the different values. So from this, we can finally derive the rate constant as Na P by sigma A B square 8 kBT upon pi u to the power r exponential minus epsilon naught by r. So this is the final derivation of the rate constant, and from the collision theory we can predict that the change in the rate will depend upon this rate constant, and this rate constant depends upon these following factors. So from collision theory, like this, we can explain the rate of the reaction. Now for activated complex theory, so one thing what important is there, that when collision theory is given, why we need the activated complex theory. So the reason for this is that collision theory has told that there need to be an effective collision to raise the energy, but it does not explain why this energy need to be raised. There has been no proof for the energy raise. So the activated complex theory was given, which proves this situation. So in activated complex theory, the theory tells us that there will be formation of activated complex. Now, what is meant by this activated? Like for example, let's say when A plus B will goes to the product. So before going to the product, in the energy diagram, I will. Now, if A and B are here, and before going to the product, they will have to pass an energy value here, like this, and they will form the product. So before going to the product, here in a state of transition state, we can say there will be a state when A and B will form some bond, or will a bond will be broken between the molecules, and this state of complex is called as activated complex. Now, why it is called activated complex? Because it is having first thing the maximum potential energy. That's why it is called activated complex. And from there, it can easily dissociate into the products. So, from this diagram, we can say that the rate of a reaction so the rate will depend on the concentration of activated complex into the frequency of decomposition. Now, for determining both these quantities, we need to study the two cases. Like for determining the concentration of the activated complex, let's determine the concentration of the activated complex. So in the formation of activated complex, we took a reaction A plus B goes in equivalent to the activated complex, which finally goes to the product. So if we write this equivalent reaction, then we find that equivalent constant is equal to the concentration of the activated complex into concentration of A into concentration of B. Now, if we use this term, then we can derive that the concentration of the activated complex equal to K into concentration of A into concentration. Now, since we know from the thermodynamics that K equilibrium, we can write as delta G equal to minus RT ln of K. So for the activated complex, we can write the delta G of the activated complex equal to minus RT ln of K prime for activated. Now, using the Gibbs equation, delta G equal to delta H minus T delta S. So if we write for the activated complex, we can write delta G for the activated complex equal to delta H for the activated complex T delta S for the activated. Now if we substitute this in this equation, we can write K of equilibrium equal to exponential minus delta H by RT into exponential delta S by R. So we got the concentration of the activated complex equal to concentration of A into concentration of B into exponential minus delta H by RT into exponential delta S by R. So we got the first term, that is the concentration of the activity. Now for the frequency of the decomposition, now in the formation of activated complex, we know that there will be a formation of bond and there will be a breaking of bond between the molecules. So if we consider the vibrational change, then we know that the 1 vibrational degree of freedom is getting converted into translational degree of freedom. Now, for this conversion of 1 degree, why it is required? Because for a bond to break, like when the A and B molecules will vibrate among themselves, the vibrational degree will exist. But when this bond of A and B will form or break, then this vibrational degree will change to the transition. And the formation of this bond requires a high vibrational energy, since we know that the E vibrational from the equation is equal to H mu. And it is something sort of 10 to the power minus 20 joule. So if we need to break a bond, then we need a huge number of vibrational energy, and for that we need a high vibrational quantum number. So for attaining that high vibrational quantum number, there will be a large disturbance in this molecule, and ultimately we can say that the vibrational energy E vibrational will be equal to the E vibrational of classical mechanics. That is equal to K E T. That is the energy for formation of 1 bond in a molecule. So the H mu will be equal to KBT, and we can write mu equal to RT upon NaH. Now, if we use both the values for mu, that is the frequency of the decomposition and concentration, we can write the rate of the reaction. So the rate is proportional, what is equal to, you can write as RT upon NaH exponential minus delta H by RT, which is a activated complex, into exponential delta S upon R into concentration of A and concentration. And if we compare with the rate law, which is given as rate equal to K, concentration of A and concentration of B, we find that the rate constant is equal to RT for NaH exponential minus delta H by RT exponential delta S by. So in the activated complex, the rate constant we can determine like this, and from this we can see that the rate constant is determining the energies of the activated molecule. So the problem that we were having in the collision theory, that it was not explained, it was not able to explain why we require an efficient amount of energy. So that has been solved from this equation, that for getting a rate to, for getting a product reactant to get converted into drug, we require a sufficient amount of energy that can be seen from this equation. So that's all for today. So now I will summarize the complete thing which I have taught. First, we discussed about the chemical kinetics, so that it is a branch of chemistry which deals with the rate of reaction. Then second point, we discussed about the rate of reaction. What is the rate? Then third thing, we discussed about the order of reaction, that it is the sum of the powers of the concentration terms in the rate law. And why we need the order of reaction, that we also discussed. Then I discussed about the different reactions based on order. That is, we discussed about zero order, first order, and second order. And then we discussed about different theories which explain the rate of reaction.
Yes, good. Good explain.
So, sir, there was one query.
Yes.
Sir, actually means the complete interview will be of 30 to 40 minutes only, maximum.
Yes,
So they will give us 15 minutes for the mock, maximum, or they will give complete time for the mock. How much time they will give for the mock?
HPPSC, UPPSC, UPHSC, maximum time is 10 to 20 minutes only.
Okay, sir.
Not more than 30 and 40 minutes. Only 10 to 20 minutes. Some basic idea
Okay.
about the basic introduction and mock interview.
So, sir, in mock, like when we are progressing from basics, like if I used to teach order of reaction and all these things, then it will be complete 20 minutes time in that. So it's better to progress on the next topics, or we should focus on basics of the topic only.
Yes. Next, we have to discuss about 3 mocks in a whole, a random mock. Yes. A whole chemistry. Yes. Next day. Something thermokinetics, electro, photo, theory. Yes. Because one is mock, the second is random interview. Yes. Random means whole chemistry.
No, sir. In mock, I was asking, like, if we teach only one topic, then in elaborative way, that's better thing, or we should touch small topics, multiple topics in small time. So which way is better? That teaching one topic in a 5 or 10 minutes time, or teaching 4 or 5 different topics like order of reaction, rate of reaction, theories in 5-10 minutes. So which one is better? I was asking this one.
Better is initial basic to high. Basic only.
Basic to high.
Yes, basic to high. Suppose that someone asks you and teach on whiteboard. Then you will explain on whiteboard basic to high. Only they want to only basic idea about teaching, how to teach you to someone. Yes.
Okay, sir.
Yes. Yes, good. Today your mock is good. And last 3 days you explains, I think, coordination, chemical kinetics, and reaction mechanics. Yes.
Yes, sir.
3 mock is completed. Yes. Next day,
Yes, sir.
random mock.
Okay, sir.
Like whole chemistry. Yes.
Okay, sir.
Yes.
So
Yes,
random mock, like in random mock, they can ask us to teach any topic, or they will ask us to teach only topics which we are
yes,
asking.
they will ask from your side. Yes,
Okay.
that's like what's your favorite topic for mock?
Okay.
Although you will tell me about that coordination, chemical kinetics, and reaction mechanics.
Yes, ma'am.
Yes. First they ask. Yes.
Okay,
Today
sir.
is completed. Your mock is very well. Last 3 day coordination, chemical kinetics, and reaction mechanics. Next day we will discuss whole chemistry. Yes,
Random.
random mock.
Okay, sir.
Yes. Thank you. Thank you so much.
Anything need to be improved, sir? Means in
Yes,
last
yes,
3 days.
yes. Yes, improve. Today also improve. Yes, good.
Okay.
Yes. Thank you.